Good afternoon, dear students. Today, we will be continuing our discussion on the properties of parallelograms. If you recall that we had started discussing that properties of parallelogram since our last session. In the last session, we discussed, three properties of parallelogram, and today we will be continuing from there. So before I proceed further, I just would like to get a confirmation from, someone of you that you are able to hear my voice very clearly
Yes,
and
sir.
able to view the screen properly.
Yes, sir.
Yes, sir.
Okay, great. Thank you very much for your confirmation. So, dear students, so what we'll be doing today is that we'll be discussing the properties of parallelograms. So the first, three properties we already discussed, and I'm just writing it here so that you can get an idea that what we have discussed earlier. So the first three properties are this. The first one is that a diagonal of a parallelogram divides it into two congruent triangles. Second one is that in a parallelogram, opposite sides are equal. And the third one is if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. And actually, if you see that, that property number 3 is actually converts of property number 2. And the proof of all these first three we discussed in the previous session. And the previous session lectures is available in YouTube, as well as it is available in the online platform at konarclasses.com. So the first three properties we already discussed. So now we will continue from the fourth property. And let me first write down all these properties, dear students, okay, so that you get an idea and what all we are going to discuss today. And then we start discussing one by one. Okay. So now, first, let me write down all the properties, and there is a total of 8 properties. And I hope you are able to view it as well properly. These are the, from property number 4 till property number 8. Okay. So the fourth property is, it says that in a parallelogram, opposite angles are equal. The fifth property is that if in a quadrilateral, each pair of opposite angles are equal, each pair of opposite angles is equal, then it is a parallelogram. Sixth property tells that the diagonals of a parallelogram bisect each other. Seventh property tells that if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. And the eighth property tells that a quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Dear students, all these 8 properties are very important. And when you start solving a problem based on this, parallelogram, you will see that you need to apply these properties in a complementary manner. So remember these 8 properties very well, very important. And I'm going to start discussing from property number 4. Before I proceed further, let me tell you the first 3 properties already discussed in the previous session. You can look into the previous session lectures too, in case you have any smallest query. Now I'm going to start with the property number 4. That is, in a parallelogram, opposite angles are equal. Okay. And let's see how we can prove that one. And that I'm going to, prove in the next, next page. The statement is that in a parallelogram, opposite angles are equal. Okay, so how to prove that one, dear students? So let us consider a parallelogram. Okay, so let me first consider a parallelogram here. Suppose, sorry. So let us consider this parallelogram, dear students. Okay, and let us name this parallelogram as A, B, C, D. So ABCD is a parallelogram. Okay. Now, what we need to prove? We need to prove that angle A is equal to angle C and angle B is equal to angle D. So what to prove? To prove that angle A is equal to angle C and angle B is equal to angle D. That we need to prove. Correct? Now, as ABCD is a parallelogram, one thing for sure that AB is parallel to DC. So AB, what we can say is that AB is parallel to DC. Correct or not? And AD is parallel to BC. And AD is parallel to BC. Quite obvious. Now, as AB is parallel to DC and AD is the transversal, okay, so let me write it down. As AB is parallel to DC, AB is parallel to DC, and the transversal AD and transversal AD, okay, the transversal AD intersect them at A and D respectively, intersects them at A and D respectively. If this is the case, then what we can say? We can say that angle A plus angle D is equal to 180 degree. Correct or not? How we can say? The angles on the same side of the transversal. Correct? So angle A plus angle D. So this implies what? Angle A plus angle D is equal to 180 degree. So based on what logic we can say? Angles on the same side of the transversal, angles of the same side of the angle of the same side of the transversal. Now, in the similar manner, if you look into that AD is parallel to DC, AD is parallel to BC, correct or not? So as AD is parallel to BC and transversal DC intersects them at D and C respectively, and transversal DC intersects them at D and C respectively, D and C respectively. So from there, what we can conclude, dear students, we can conclude that angle D plus angle C is also equal to 180 degree. So angle D plus angle C is equal to 180 degree. Using the same logic as I said earlier, that angles on the same side of the transversals. So angles of the same side of the transversal. Dear students, so as I am solving, you can also write it down. So what we get, A plus D is equal to 180 degree and D plus C is also 180 degree. So what we can say? We can say that A plus D is equal to D plus C. So from this and this, what we can conclude? We can conclude that angle A plus angle D is equal to angle D plus angle C. So both sides angle D got cancelled, and what we get, dear students, angle A is equal to angle C. Correct? Fine. So this is
Yes, sir.
one proof we are able to do, that in a parallelogram opposites angles are equal, A equal to C. In the similar manner, we can prove angle B is equal to angle D. Similarly, we prove angle B is equal to angle D. And I hope you got it, that how to prove angle B equal to angle D, right? Same concepts of two parallel lines and there is a transversal. Correct, dear students? Everything is clear? So, any doubt at any point of time, do let me know. So as we are done, that
Yes.
let me go to the, thank you. Let me go to the next property. So fourth property was what? In a parallelogram, opposite angles are equal. Okay. Now the fifth one, let me write it down in the next page, and we will discuss more on it once. Let me first write it down. So dear students, here the fifth property is that in a quadrilateral, if in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. And if you see, dear students, it is as if the converse of the previous property 4, isn't it? Do you get this point, that why it
Yes,
is?
yes, sir.
Okay, great. So now, how to prove that one? So for that, let us first construct a parallelogram. Okay, and sorry, a quadrilateral. Okay, not parallelogram. If in a quadrilateral, so we construct a quadrilateral in which the pair of opposite angles is equal. And dear students, that that quadrilateral, as it is going to be a parallelogram, so from the beginning only, the quadrilateral shape should be looks like a parallelogram. Okay, so suppose this is A, B, C, D, be the quadrilateral. This is a quadrilateral. Okay, in which the opposite, each pair of opposite angles, is equal. That means what? Angle A is equal to angle C, and angle B is equal to angle D. Correct, dear students? So what we get is that according to the question, ABCD is a quadrilateral in which, given. So what is given? Given is that angle A is equal to angle C and angle B is equal to angle D. So these are the two information given to us. Now, what we need to prove? we need to prove that ABCD is a parallelogram. What to prove? To prove, so let me write properly. To prove that ABCD is a parallelogram, that we need to prove. Now, how we are going to prove? Let me show you. Now, if you recall that angle sum property of a quadrilateral, we know from the angle sum property of a quadrilateral that sum of these four angles is equal to 360 degree, correct or not? So from that, what we can say is that because ABCD is a quadrilateral, that angle A plus angle B plus angle C plus angle D, that is equal to 360 degree, right? The angle sum property of a quadrilateral. Okay, so what we can write is that from the angle sum property of a quadrilateral. So now, dear students, according to the question, it is given that angle C is equal to angle A. So what we can write from here, that we write angle A plus angle B plus angle C, we can write angle A, and angle D, we can write angle B, that is equal to 360 degree. Correct or not? So what we get? We get is that 2 times angle of A plus B is equal to 360 degree. That implies 2 times angle A plus angle B is equal to 360 degree. And eventually we get that, angle A plus angle B is equal to 180 degree. Correct, dear students? Okay. Now, what we can say, dear students, is that what we get is that angle A plus angle B is equal to 180 degree. So that implies that angle C plus angle D is also 180 degree, because angle A plus angle B plus angle C plus angle D is actually 360 degree. So from here, what we can conclude? From here also we can conclude that angle C plus angle D is equal to 180 degree, since angle A plus angle B plus angle C plus angle D is equal to 360 degree. Correct, dear students? Now, what we can do from here, angle A plus angle B is equal to angle C plus angle D is equal to 180 degree. Now, let's look into it, that the transversal AB, if you look into the diagram, the transversal AB intersect AD and BC at A and B respectively, such that angle A plus angle B is equal to 180 degree, which are angles of the same side of the transversal. And that from that information, what you can conclude, that AD is parallel to BC. So let me explain you what I wanted to mean. So what we can write is that, so I'm writing it here, since the transversal AB intersect AD and BC, intersects AD and BC, AD and BC. That's a small mistake I have done it here. So it is AD, the transversal AB intersect AD and BC at A and B respectively, at A and B respectively, such that angle A plus angle B, angle A plus angle B is equal to 180 degree, which are angles on the same side of the transversal, which are angles on the same side of the transversal. All of you are able to get it, dear students? Okay. Dear students, could you please confirm that you are able to get each and every statement very clear?
Yes, sir.
Okay. So what we see is that the transversal AB intersects AD and BC at A and B respectively, such that angle A plus angle B is equal to 180 degree, which are angles on the same side of the transversal. So from this information, what you can say is that AD must be parallel to BC. So from here, what you can say is that AD is parallel to BC. Correct? This is an important information. Correct? Now, in the similar manner, we can prove that AB is parallel to DC. Okay. So, you know, what we see is that how, let me explain further. What we see is that angle A plus angle B is equal to 180 degree. Okay, so this is one result we got. Okay. Now, what we get is that angle A plus angle B is equal to 180 degree. Angle A plus angle B is equal to, sorry, angle A plus angle B is equal to 180 degree. It is given, and according to the information, we know that angle A is equal to angle C. So from here, what we can write? So from here, we can write that angle C plus angle B is equal to 180 degree, since that angle A is equal to angle C. Correct? No? So what we can say from here is that if you look into the diagram, that BC, the transversal BC, intersects AB and DC at B and C respectively. So what I'm saying is that if you look into the diagram, that the transversal BC, intersect AB and DC at B and C respectively, such that angle B plus angle C is equal to 180 degree, which are angles on the same side of the transversal. So we can conclude that AB is parallel to DC. So let me write it down, dear students. So as we have looked into this statement, transversal BC, sorry, transversal BC intersects AB and DC, sorry, intersects AB and DC at B and C respectively, at B and C respectively, such that angle B plus angle C, angle B plus angle C is equal to 180 degree, which are angles on the same side of the transversal, which are angles on the same side of the transversal, which are angles on the same side of the transversal. So from here, what we can conclude? We can conclude that AB is parallel to DC. So from here, we can conclude that AB is parallel to DC, dear students. So, we got AD is parallel to BC. So let's keep this, the result 1. And then we get now is that AB is parallel to DC. So from 1 and 2, what we can conclude? That from 1 and 2, we conclude that ABCD is a parallelogram. ABCD is a Dear students, is it absolutely clear?
Sir, I have one doubt.
Yeah, please.
Sir, in this question, can't we just say that since the pair of opposite angles are equal, it's a property of parallelogram, so it's a parallelogram?
And now, if you look into the statement, here the question, in the property is giving that it is a if in a quadrilateral. If in a quadrilateral, so the statement starts with that if it is a if in a quadrilateral. So we assume that ABCD is a quadrilateral. Each pair of opposite angles is equal. And with this condition, we need to prove that it is a parallelogram. Correct. But
Okay, sir.
But the converse of this statement, what you said, it is a converse of this statement. That we know, if you look into the previous one, that in a parallelogram, the pair of opposite sides are equal. Correct or not? That's what we have proved in the previous one. Correct. Correct.
Yes, sir.
If you look into the previous one,
Yes, sir, we
the
proved
opposite
that.
angles of a parallelogram are equal. That's what we have proved. Right. Now let's proceed to
Yes,
the dear
sir.
students. So let me proceed to the next one, that property number 6. And before I proceed to property number 6, this property number 5 and its explanation is absolutely clear to each one of you, dear students.
Yes, sir.
Okay, okay, great, fine. Now let me go to the next one, and that I'm going to tell you here, dear students. Okay, the property number 6, it says that the diagonals of a parallelogram bisect each other, and that I'm going to prove it to you. So the statement, what you see, dear students, the diagonals of a parallelogram bisect each other. And what I'm going to do, dear students, I'm going to, prove it. How we are going to prove it, that is the part of the discussion. So first of all, dear students, so let me use a different color. So first of all, let me construct a parallelogram first. Okay, because we need to start with a parallelogram. Okay, so this considered that ABCD is a parallelogram, dear students, and the the diagonals of a parallelogram. So let me construct the diagonals. So this is one diagonal. If I join A and C, and then we join D and B, this is another diagonal, and these diagonals intersect each other at the point, suppose O. Okay, dear students, so we assume that they intersect at the point O. What we need to prove? We need to prove that OA is equal to OC and OB is equal to OD. What is given? It is given a parallelogram, okay, and ABCD such that the diagonals AC and BD intersect at O. So let us start what is given. What is given? Given is that ABCD is a parallelogram. ABCD is a parallelogram such that the diagonals AC and BD intersect at O. Fine. And what to prove? What to prove? We need to prove that OA.
Sir, OA equals OC.
Yes, that we need to prove, and OB is equal to OD. And let's see how we are going to prove it. Now, dear students, as you see that ABCD is a parallelogram, definitely we can say that AB is parallel to DC and AD is parallel to BC. So here I am going to prove it. Okay. Since ABCD is a parallelogram, since ABCD is a parallelogram, definitely we can say is that AB is parallel to DC, AB is parallel to DC, and AD is parallel to BC. AD is parallel to BC, correct? And so as these two informations are given, let us look into the that when AB is parallel to DC and AC is a transversal, as so I'm writing it here, dear students, as AB is parallel to DC and AC is a transversal, and AC is a transversal. So what we can conclude? We can conclude that angle ABD is equal to AB is parallel to DC, AB is parallel to DC, and AC is a transversal. So definitely angle BAC is equal to angle DCA, and this angle is equal to this angle. Correct or not? So what you can conclude from here, that angle BAC is equal to angle DCA. And now angle BAC, from here what we can say is that is angle BAO. From here what you can write, that angle BAO is equal to angle DCO. Correct? Obviously it is correct. So let's keep this as equation 1. So in the equation 1, what we get, dear students, that angle BAO is equal to angle DCO. Now, let's come to the another statement, dear students, is that AB is parallel to DC and BD is a transversal. Okay, so I'm just going to write it down here that so again AB is parallel to DC and BD is a transversal and BD is a transversal. So from here what we can say, dear students, we can say that angle ABD is equal to angle CDB. Angle ABD is this one, is equal to angle CDB. So from here what we can say, dear students, that angle ABD is equal to angle CDB, and that eventually says that angle ABO is equal to angle CDO. Angle ABO is equal to angle CDO. Correct, dear students? So this we give at equation number 2. Now let us consider two triangles. The first triangle is angle first triangle is the triangle AOB, and the second triangle is the triangle COD. Okay, so now in the triangles, AOB, AOB and COD, AOB and COD, we get angle BAO is equal to angle DCO. Angle BAO is equal to angle DCO. Angle ABO is equal to angle CDO. Okay, and that AB is equal to CD. AB is equal to CD. AB is equal to CD. Now, dear students, with these three informations, can't we say these two triangles are congruent to each other by means of that ASA congruency? So what we can say is that the triangle AOB is congruent to triangle COD by ASA congruence. By ASA congruence. So from here what we can say, as these two triangles are congruent to each other, so what we can say, OA is equal to OC. So that implies OA is equal to OC and OB is equal to OD, and OB is equal to OD. So we get OA is equal to OC and OB is equal to OD, because that is you can say that by CPCT, correct? So by CPCT. So now as we get OA is equal to OC and OB is equal to OD, we are able to prove what we wanted to prove, and eventually we make that statement that the diagonals of a parallelogram bisect each other. Any question, dear students, before I proceed to the next property? Is absolutely clear?
Yes, sir.
Yes, sir.
Okay, great. Thank you very much. Now, let me go to the next property, and that property I am going to discuss here. And the next property I'm going to write it down here first. And this property says that if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Okay, dear students. So let me first place the statement and then let me prove it. So the statement here, the property statement here is that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And if you notice, dear students, this is just a converse of the previous property, right? In the property number 6, whatever we discussed, that is, it is a converse of this thing. In the property number 6, we said the diagonals of a parallelogram bisect each other. And here we are going to discuss is that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So we are going to prove it, dear students, and let's see how we are going to prove it. Okay. So let's first, take a quadrilateral and let me prove it with a different color. Let me use a different color. Yeah. So dear students, you may think that, sir, you told that you are going to take a quadrilateral, but looks like that you are taking a parallelogram. The point is, dear students, that ultimately you need to prove that it is a parallelogram. So that is why I took this quadrilateral something like this. And if I do not give it a shape of parallelogram, then that statement will not be very meaningfully established in the diagram that bisect each other. The diagonals of a quadrilateral bisect each other. If I take very generic quadrilateral, and if I draw that, if we take the diagonals, you'll see that they are not bisecting each other. So that will not be very a good way of proving, right? So now, dear students, what is given here? It is given, we have been given a quadrilateral ABCD, and we have the diagonals AC and BD. So let me draw the diagonals first. This is diagonal AC, and this is another diagonal BD. And these diagonals, they actually intersect at the point O, dear students. Correct? Okay. So what is given? It is given is that, let me write it down, what is given. A given is that a quadrilateral quadrilateral ABCD, in which the diagonals in which the diagonals AC and BD intersect at O, such that AO is equal to OC, and BO is equal to OD, and BO is equal to OD. That is given. Okay. And what you need to prove? We need to prove that the quadrilateral ABCD is a parallelogram. So to prove quadrilateral ABCD is a parallelogram that we need to prove. Okay. Now, how we are going to prove it? So now we are going to prove it. Dear students, if you look into the two triangles that AOD and COB, okay, so in the triangles AOD and COB, okay, what we are going to get? According to the statement, it is given that OA is equal to OC, OA is equal to OC, OD is equal to OB, and angle AOD is equal to angle COB because they are vertically opposite angles. So OA is equal to OC, that is given. OD is equal to OB, that is also given. And obviously this angle, that is AOD, is equal to the angle COB, and angle AOD is equal to the angle COB. Okay, dear students. So from this information, what we can conclude? We can conclude that these two triangles AOD and COB are congruent to each other by means of that SAS congruence. So what we can say is that triangle AOD is congruent to the triangle COB by SAS congruence. SAS. Correct, dear students? Now, as these two triangles are congruent, what we can say? By CPCT, we can tell that angle OAD is equal to angle OCB. So this implies angle OAD is equal to angle OCB. Angle OAD, this angle, is equal to the angle OCB, means this angle. Now, dear students, the line AC intersect AD and BC at A. Mind my statement very carefully. As line AC intersect AD and BC at A and C respectively, such that angle OAD is equal to angle OCB, which form a pair of alternate interior angles. Definitely, we can say that AD is parallel to BC. Correct or not? So what I'm going to write is that, so I'm going to write it down, dear students, so that you get that exact idea. And here is my statement. As the line AC intersects AD and BC, at A and C respectively, at A and C respectively, such that angle OAD is equal to angle OCB, which form a pair of alternate interior angles which form a pair of alternate interior angles. Let me write it here. Alternate interior angles. So from here, what we can conclude? We can conclude AD is parallel to BC. That implies AD is parallel to BC. In the similar fashion, same manner, similarly I can write similarly what we can write is that AB is parallel to BC. Okay. Now, if we combine these two together, that AD is parallel to BC and AB is parallel to DC. Okay. So from here, we can conclude from these two information, we can conclude that ABCD is a parallelogram. So ABCD, which we took as a quadrilateral, it is turning out to be a parallelogram. ABCD is a correct. Clear? Absolutely clear, dear students. Any doubt? Please do let me know.
No, sir.
Okay, great. Now we are going to discuss the next property, and the next property is something like this, that let me write it down. A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Okay, that is quite a fundamental definition of parallelogram as well, we can say, and we are going to establish that, dear students. Okay, so the statement here is that, as you see, a quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Okay, and I'm going to prove it, dear students. So here what we'll take? Here we'll take a quadrilateral. So let me take a quadrilateral here, dear students. So let me take this, let me prove it in a different color, green color, suppose. So as you see that ABCD is a quadrilateral here, okay, and a pair of opposite sides, that is AB and DC, we take these two opposite sides, they are equal. That means AB is equal to DC and they are parallel. So let me write it down. What is given, dear students? So it is given is that a quadrilateral ABCD, a quadrilateral ABCD in which AB is equal to DC, AB is equal to DC and AB is parallel to DC. Correct? This is given, and what to prove? To prove that ABCD is a parallelogram. to prove that ABCD is a parallelogram. Now, to prove that one, dear students, I need to make a small construction, and that construction is that I need to just join AC. So what is the construction? So dear students, the way I'm writing, exactly this is the way you need to also write when this proof comes in the exam. Okay, so what I'm going to do is that I'm just going to, join AC. Okay. Join AC. Correct, dear students? Now I'm going to prove it. So here is going to be the proof. If you look into the two triangles, the triangle ABC and triangle CDA, so in the triangles ABC and CDA, generally we denote triangle with a small triangle symbol here. In the triangle, so let me write it very clearly, dear students. Sometime in the digital board, my writing is not that great. In the triangles ABC and the triangle CDA. Dear students, though my handwriting is not that great, but you are able to understand, right? Whatever I'm writing. Dear students, could you please respond?
Yes, sir.
Yes,
Sir,
sir.
we can.
Okay. So in the triangle ABC and CDA, what we are going to get is that AB is equal to CD. AB is equal to CD and AC is equal to CA. Okay. There is a why I write AC not equal to AC. AC is equal to AC, it is quite obvious. But here writing AC is equal to CA because I'm going to prove the congruency. And dear students, that what is the next point is that next point what we are going to say is that AB is equal to CD, then AC is equal to CA, and what we see is that angle BAC, okay, angle BAC is equal to angle DCA. What I wanted to mean is that this angle is equal to this angle. Why we can say this thing? Because they are alternate interior angles. So angle BAC is equal to angle DCA. So angle BAC is equal to angle DCA, and they are alternate interior angles. Alternate interior angles. Correct, dear students? The moment we get this thing, okay, with these three informations, that is AB is equal to CD, AC is equal to CA, and angle BAC is equal to angle DCA, what we can say? We can say the two triangles ABC and CDA, okay, they are congruent to each other by means of SAS congruence. Correct? So with these three informations, what we can conclude? We can conclude that triangle ABC is congruent to the triangle CDA. SAS congruence. Sorry. Sometime in the digital board I face problem. Okay, now one thing very important here. Look into the the sequence of the different letters I'm writing. AB is equal to CD. The moment AB is equal to CD, your when you write the congruency, the sequence of A and C and AB, sorry, AB is equal to CD, the sequence of AB and sequence of CD will remain intact. When we write AC is equal to CA, look at AC is a sequence in the left hand triangle and CA is the sequence in the right hand triangle. I explain these things in details when we discuss about the congruence of two triangles, the lectures of which is available in the online test platform as well as in YouTube. You can look into it, but look into this sequence. That sequence is very important, and that is why I wrote there AC is equal to CA, dear students. An angle BAC, you see the B, then A, then C. Similarly, it should be DCA here also. You see that BAC, the way B after that A and after that C. Similarly, from D it is coming to C and from C to A. Exact sequence you need to maintain. If you do not make exact sequence, it will create confusion. So that is very important. So now let's come back to our discussion. So that we are able to prove that the triangle ABC is congruent to the triangle CDA. Now, as these two triangles are congruent to each other, dear students, what we can conclude? We can conclude that angle BCA is equal to angle DAC because by means of CPCT. So what we can conclude? So from here we can conclude is that angle BCA is equal to the angle DAC by CPCT. Angle BCA, if you see the angle BCA is this one, is equal to angle DAC is this one. Okay, dear students. Now, the line AC intersect AB, AD and BC. Okay. Look into, just concentrate on my statement, what I'm saying. After that, I'll write also. If you look into this, that line AC intersects AD and BC at A and C respectively, such that DAC, the angle DAC is equal to angle BCA, which form a pair of alternate interior angles. And what we can conclude? We can conclude that AD is parallel to BC. Let me write it down, whatever I just said. So let me write it down here, dear students. Is that the line AC intersects AD and BC intersects AD and BC at A and C respectively, at A and C respectively, such that angle DAC is equal to angle BCA. Angle DAC is equal to angle BCA, which form a pair of alternate interior angles. Which form a pair of alternate alternate interior angles. So from here, from this statement, what we can conclude? From this statement, we can conclude that AD is parallel to BC. So AD is parallel to BC. That we are able to prove it. And if you recall, it has been given that AB is parallel to DC. It was given. If you look into this, in the given, we have this thing, no? That AB is parallel to DC. AB is parallel to DC. Now, if we combine these two, dear students, so from here, what we can conclude? That ABCD is a parallelogram. That implies ABCD is a parallelogram. I hope, dear students, you got a very clear idea about all these 8 properties. Any questions so far, dear students? Any questions? Could you please reply, someone, please, that you get any confusion, any question here, dear students?
No, sir.
No, sir.
Absolutely clear, right? Now,
Yes, sir.
what you need to do is that you need to go through these properties once more. Once my class is done, once you get, that video lecture of my class, along with these class notes, that will be available to you, after the class. After that, what you need to do, you need to go through these class notes and my video lecture once more very minutely. And it will give you a very good confidence about the 8 properties what I just said, in the beginning of the class. After that, what you need to do, dear students, that I'm going to show it to you. I'm just going to, share a different window, and just going to share another, you are aware of it. So this website, konarclasses.com. First you go there. Could you please confirm that you are able to view this www.konarclasses.com, dear students?
Yes, sir. Yes, sir.
After that, you just click into login, give your login and password. And after that, once you go through all these properties of parallelogram, dear students, after that, you click into that write online examination. Click into write online examination. And then here you just write quadrilateral and go through the set 2. Set 1 already assigned, set 2. And here is the instruction. As you read the instruction, after that you go for the right test and you start getting 10 questions, as you are aware of, and you need to answer those 10 questions. Make this scan copy, you upload. Once these are all descriptive questions. Once these questions are answered, scan those pages, your answer paper, and make it a PDF file, and then finally upload that answer. So, dear students, with this, we are done with the properties of the the parallelogram. In the next session, what we are going to discuss, we are going to discuss about that, the other properties of, and that is the properties of that point theorem, that we are going to discuss in the next class. And with this, I would like to conclude the class for today, unless you have any specific question for me.
Sir, we have a class on Saturday, right?
Yeah, Saturday class I will communicate to you with exact time. So for that you need to give me some time. I'll communicate to you exact time, and this will be communicated to you our I'll communicate to our email. Okay.
Okay, sir. Thank you,
But
sir.
what I'm talking about is that in the next class, mathematics class, we will be discussing about the midpoint theorem. So midpoint theorem is very important. And but before midpoint theorem, what you need to do, as I was telling, that you need to go through this, class note of today and the video lectures once more, very minutely. Look into the way I proved all these properties. Make yourself comfortable. Then appear for that, the daily practice problem of the set 2 of quadrilateral. Submit your answer by uploading the scanned copy. And then in the next mathematics class, we'll be discussing that the midpoint theorem. With this, I would like to conclude the class here, dear students. If you have any specific question, please do let me know. All are clear? Okay. Thank you very much.
Thank you, sir.
Thank
Thank
you.
you, sir.
Thank you.
Thank you,
Thank you,
sir.
sir.